Okay, good morning everyone. Today what we're going to do is we're going to work on exponents as we move on to our next level of algebra. We're kicking it up a notch, and that means we're going to do slightly more difficult tasks, but are they really that difficult? Nah. It's more like it's just a skill that we're practicing, and we're adding to what we know before. So what we're doing is we're doing with exponents. And what exponents really are, it's a fast way of multiplication. So it's a fast multiplication. And multiplication is actually a fast addition. Right? So we're kicking it up. We've been multiplying variables. Today we're going to work on just simple reminders of what are exponentials. So what is our exponents? So here we go. What are exponents? Exponents are a fast way of writing multiplication. If I write 3 squared is a fast way of me writing 3 times 3. Okay? 3 cubed this isn't 33, okay? This is not 33. That's not 33. This is me saying, hey, the notation as a superscript, I guess that's the term, superscript, it's this little tiny letter that's written in the right corner of things. This means I'm going to write 3 times. If we go 3 to the 4th power, this is 3 times 3 times 3 times 3. Right? So the idea is that we're writing this out as many times as we need to, but which one would you prefer? Would you rather write it in exponent form or in multiplication form? Right? Both these mean exactly the same thing. 3 squared, this is term 3 squared, or 3 cubed, and then as we moved up, we would say 3 to the 4th power. Okay. Look at 27, and 27 times 3 is 81. Okay, or you can do 9 times 9 is 81. Okay, so exponents are they're not that hard if you know your multiplication tables. But of course, as they get bigger, we need to start using a calculator, right? So we can go back and forth with this. And one of the skills that we want to talk about is first simply just what do I do with exponents? If I see 5 squared plus 5 cubed, do we have 5 to the 5? Because we're adding them? And I want you to say this is not true. Okay, this is not true. This is bad. Now, why is this bad? Because, well, aren't we adding? Can't we just combine like terms? Now, you might think that these are like terms. But what if I wrote this a different way? What if I wrote x squared plus x cubed? Are these like terms? No, they're not like terms. What we're saying here is we have 5 times 5. Over here is 5 times 5 times 5. Now, just because you kind of look alike, does it mean you're alike? Answer here is no. 5 squared and 5 cubed are totally different. 5 squared is actually 25, and 5 cubed is 125. And that's our issue when we look at variables with exponents. Why could I not add x squared and x cubed together? Why were they two different terms, separate terms? It's because they weren't the same type of group. If I wrote instead, if I wrote 5 squared plus 5 squared, well, how many 5 squares do we have? We have 2 5 squares. That's a fancy way of writing it. Because remember, multiplication is just fast addition. If I wrote this a little differently, if I wrote 5 plus 5 without the exponent, don't I have 2 5s? If I write it in variables, x squared plus x squared, well, how many x squares do you have? You have 2 x squares. To make this a little easier, if I say 5x squared plus 3x squares, well, I have 5 second graders and I have 3 second graders. I have a total of 8 second graders. So why is it we can combine them if they have a number in the front that's not the same, but we can't combine them together if the exponents are not the same. Because they're totally different classes of numbers. What I mean by that is, if you look here, actually looking at the 5 squared here, isn't 5 squared a nice 25? But a 5 cubed is 125. These are totally different groups of numbers. But if I say right here, 5 squared and 5 squared, hey, isn't 25 and 25 the same type of number? They're both 25s. So how many 25s do we have? Well, we have 2 25s. And that's another way of saying 50, because 25 plus 25 is 50. I'm making this sound like a little confusing here, doing a lot of examples at the same time. But the takeaway is this. If they have the same exponents, the same variable with the same exponents, yes, we can add them because they're the same type of group. Let me give you another example of this. If I say 4 squared plus 4 squared plus 2 to the 4th, will these be the same numbers? Well, as you can see, this is what we call the base and the exponent. This is what we call the base and the exponent. Oh, sorry, base and power, wrong word. The whole thing is considered an exponent, power. Well, how many 4 squares do we have? We have 2 4 squares. But can we actually add this 2 to the 4th here? Well, what is 2 to the 4th? Well, what's 4 squared to begin with? 4 squared is actually, 4 times 4 is 16. And 2 to the 4th is 2 times 2 times 2 times 2, which is also 16. So in this weird case, we kind of lucked out. But could you add them together? Answer is no, we shouldn't combine them. If I switch this to x squared plus x squared plus y to the 4th, this becomes a little more easier to look at because the variables do not match. We have 2x squares plus a y to the 4th, which is separate. Now just a quick review of the parts of an exponent. Exponents, parts. If I say 5 squared equals to 25, okay? So the whole thing is called an exponent. These are called exponents. But there's actually made up of small parts. This is called the base. The base is what we're repeating. Over here, it's the power. The power is how strong it is. How many times are we going to repeat that? For specific types of exponents, we have fancy words for them. If I say 5 squared, right? This is 5 squared. If I say 5 with a 3 in it, we term this as 5 cubed. Now I have a question for you. If you guys could figure this out. If I say 2 to what exponent is equal to 8? 2 to what exponent is equal to 8? Well, if you guys have a calculator, all you have to do to figure this out, you say 2 on your calculator times 2. And that becomes 4. Okay, so we're not there yet. So you multiply by 2 again, and then we have 8. So how many 2's did it take us to get there? It took us x is equal to, it took us 3 times. So another way of looking at exponents is we can solve for x, but only in this guessing way. We'll have a more solid way of doing it in Algebra 2 and pre-calculus, but for us, for now, solving for exponents is something that we will leave to Algebra 2. What if I ask you, what is 10 to the x power equals to, let's do 10,000 here. Okay. 2 cubed. That's right, 2 cubed. So 10 to the what exponent? What do you think x would be? And there's actually a very nice trick for tens. Close. The nice trick for tens is that we just look at the zeros. How many zeros do we have? We have 4 zeros, and that'll be 10 to the 4th power. So x equals to 4. And if you want to check, let's say 10 times 10 is 100. 100 times another 10 is 1000. Whoops. 10 to the... Wait, 10 times 10. Oh yeah, sure. And then 10, 1000 times 10 again is equal to 10,000. And if we look here, we have 1, 2, 3, 4 tens. Good guess though. Okay. So we would write 10 to the 4th power. And one trick for zeros is that we just count the number of zeros, number of spaces. Now what happens if we have negative numbers? So we have to take a look at how the negative numbers are written. If it's negative 2 cubed versus negative 2 cubed, and this is a trick question here. In this case, they would yield the same answer. They would yield the same answer, but there's a different way of doing both of these. Now, let's go back to look at PEMDAS. Please excuse my dear Aunt Sally. Okay? Parentheses. Exponents. Multiplication. Division. Addition. And subtraction. Okay? What do we do first in the case number 1? We'll call this case number 1 and number 2. In number 1, do we multiply by negative 2 first, or we do the exponents first? Looking at PEMDAS, we do the exponents first, and then we do multiplication. So in this case, we want to say negative. First, it's 2 cubed. So this is one that tricks kids all the time. Okay, and kids will say, Mr. Go, how do I read this? Do I take the negative with it? Do I cube it 3 times, or do I leave the negative on the outside? And it's really back to order of operations. What do I do first? Do I do the negative or the exponent? If you look here, negative 2 cubed is actually negative 8. Because 2 times 2 times 2 is 8. We're left with negative 8. But if you look on the right here, it'll actually give us the same answer. Because what is negative 2 times negative 2 times negative 2? Negative, negative, negative is still negative 8. Okay, if you're not sure about the signs, these two become positive, but a positive times a negative gives you back a negative. Now I'm going to do this with a different example, slightly different. If I write negative 2 to the 4th versus negative 2 to the 4th within parentheses. Okay. So my first example, which will trick kids a lot, they'll say, hey, look, doesn't the negative cancel out? And the answer is no. If I write this like I meant to write it, we do the exponent first. Exponent first. So we actually have negative 2 times 2 times 2, 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 4 is 16. So that's actually negative 16. But on the right, negative 2 times negative 2 times negative 2 times negative 2 is positive 4, positive 4, positive 16. These are not the same answer, though they look so similar. What is the difference between these two? On the left, we are saying, again, negative times 2 to the 4th power. What do we do first? We do the exponents first, and then followed by the negative second, because of PEMDAS. But when we look over here to the right side, negative 2 to the 4th power, we actually do the parentheses first. So it's almost like a puzzle game. When you read a math problem, you're reading a puzzle game. What do you do first? How do you play the game so that you're playing it right? Now we also have one more special trick here that we want to make sure we're cool about exponents. Is this value. And I want to have you guys just memorize it now, and we'll try to prove it later. But if I write anything to the 0 power, and you probably remember this from 8th grade, but if I write 3 to the 0, or 4 to the 0, or 5 to the 0, or 6 to the 0 power, anything to the 0 power is equal to exactly 1. Anything to the 0 power is equal to 1. X to the 0 power is 1. So whenever you see anything to the 0 power, that's exactly 1. And we'll receive the reason why for this later. So you have to memorize this for sure. Even if you see something like e to the 0 power, that is 1. Pi to the 0 power is 1. Anything to the 0 exponent is equal to 1. Okay. How about this? What if I say 4 to the 1 power? How many 4s do we have? We have exactly 1. So it's just 4. 5 to the 1 power? That's just 5. Anything to the 1 power, anything to the 1 power is itself. Because how many do you have? 1. Imagine if you had one $10 bill. How much do you have? You have $10. We have one $20 bill. You only have $20. Okay. So we looked at easy numbers and easy variables with exponents. Now, what about if I gave you guys a fraction? Okay, and let's look at fractions now. You guys don't like fractions, but it's something that we have to conquer. So let's take a look at fractions. If I say 3 over 1 squared, what we're saying is 3 over 1 times 3 over 1. Well, isn't that 9 over 1, which is just 9? Well, that's the same thing if I just wrote 3 squared, which is 3 times 3, which is equal to 9. So when we're squaring fractions, we just multiply the same thing over and over. What's on top gets multiplied on top, and what's on bottom gets multiplied on bottom. If I say my example is 1 over 2, what is 1/2 squared? Well, if you write it as 1 over 2 times 1 over 2. 1 over 2 times 1 over 2 is 1 over 4. Or know what? We can also write this as 1 over 2 times 1 over 2 is 1 squared over 2 squared, which is 1 over 4. If I say 3 over 4 squared, well, we could have wrote 3 times 3 and 4 times 4, which is 9 over 16. Now, this is easy for me writing out for easy values, for really simple squares. But we can also again write this. This is the same as, now here is the rule. When you are taking the exponent of a fraction, exponents of fractions, you can share the exponent. Okay, what I mean by share the exponent is that if we have 3 over 4 squared, we can share the exponent to both the top and the bottom. 3 squared over 4 squared. And that's a rule that we can do. If we're multiplying, so if we're taking the power of a fraction, we can share that exponent. Now, why could we do this? Well, if we go back here, didn't we say we were going to have 3 over 4, again a 3 over 4. So we were going to write as many exponents as we had. Since we have 2, we're going to have 2 now. We're going to have 2 now. Okay. So let's look at another one. If I say I have 2 cubed over, let's say 3 squared, and I square it. Okay. Let me write it out first. We have 2 cubed over 3 squared. How many times are we going to write it? We're going to write it twice. 2 cubed over 3 squared. So take a look here, please. I said my exponent is 2, so I'm going to write this out twice. Now we're going to have to combine these. And when you multiply fractions, please be comforted. When you multiply fractions, you multiply the top by the top and bottom by the bottom. Top by top, bottom by bottom. Well, if the top is 1, 2, 3 2's, and 1, 2, 3 2's, how many 2's do we have on top then? We're multiplying, 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 multiplying. We have a total of 2 to the 6. How do you guys feel about that? 2 to the 6. On the bottom, we have 3, 3, and 3, 3. So how many 3's do we have total? 3 to the 4th. Now, I want to ask you guys this follow-up question. We're taking a jump here, but can you think of an easy way to start from getting from here to here without going through this huge mess in between? Can you think of a way of getting from here to here without doing all the work in between to save us some time? You got it. Okay, someone just messaged me and said just multiplying. And that's actually the trick for multiplying powers. This is called the power of powers of powers. Wait, power of powers. Yes, power of powers. So we're taking exponents of powers. What we do is we multiply the exponents. So 3 times 2 is 6, and 2 times 2 is 4. Let me give you one last one. If I say x to the 4th over 5 cubed to the 5th power. This part's a little crazy, okay? Well, we said if it's a power of a power, we have to just multiply it. So how many x's do we really have? 4 times 5 is 20. And how many 5's do we have on the bottom? 3 times 5 is 15. Now, I'm going to do something stupid here. I'm going to write it out 5 times. 1, 2, 3, 4. Don't copy this. 5. And 1, 2, 3, 4, 5. And we're multiplying them all together. We're multiplying them. So how many x's do we have? Well, if I want to count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We actually had 20 x's here. And the thing is, us knowing these rules save us time. Just like when we learn our multiplication tables. We learn our multiplication tables to save us time instead of having to add 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus 5. Okay? We learned a way of multiplying instead. So exponents are the fast way of multiplication, and we want to know our rules to make it faster for us. Okay, so actually, you know what? I'm going to. Okay, now we have one more. Oh, let me go ahead and go through the fractions one more time. So what if I give you guys again 1 over 2 cubed now, okay? What's 1 over 2 cubed? So we could say the classic way is 1 over 2, 1 over 2, 1 over 2. And you might say, Mr. Ko, that takes forever, right? But 1 times 1 is 1, and 2 times 2 times 2 is 8. But the fast way, as we just talked about, is multiplying our exponents by each other. So there's an invisible 1 here. So I have 1 cubed over 2 cubed, which is 1 times 1 times 1, and 2 times 2 times 2, which is a lot faster. Now, if you don't see a number in the exponent, it's an invisible 1 and invisible 1. Oh, sorry, this is a 2. Okay. There's always an invisible 1 next to an exponent, next to a value, because I have one of them by default. Now, on your homework, they're going to trick you. They're going to give you guys, for instance, something that looks like a decimal. Let's start for 0.5. And let me ask you, isn't 1/2 the same as 0.5? 1/2 the same as 0.5, right? 50 cents, half a dollar. Now, what if I asked you to multiply this 3 times by itself? To do this, I mean, it's not super hard, but we would have to go back and memorize how to multiply multiply decimals. So instead, I'm going to teach you guys a different way to rewrite this, and this is how IXL wants you to write it. Instead, what's the fraction of 0.5? That's the same fraction as 5 over 10. Please take a look here. Whenever you have a tenth in decimal, it's because we are dividing it by tens. You have 10 dimes. Then we do another problem at the same time. What if I write 0.2 cubed? Okay, same type of style. We can write 2 out of 10. We can change it to it's a tenth. We can change it to a fraction of a 10. Why am I saying this? Because it actually makes the problem a little easier. Okay, from here, you can either keep it as it is or reduce if possible. So I'm going to take 2 paths. Okay, 2 paths. Reduce and not reduce, and it's up to you. So if I don't reduce, it's going to be 5 cubed over 10 cubed. 5 times 5 times 5. 5 times 5 is 25. Times 5 is 125. It's 125 over, now remember we talked about multiplying by tens. 10 cubed, it's 10, 1 with 3 zeros. That's how fast it is to do cubes, or to do tens. What if I reduced 1 over 2? 5 over 10 is same as 1 over 2. Cubed. And that's going to be 1 times 1 times 1 is 1 over 2 times 2 times 2 is 8. Turns out 125 and 1/8 are actually the same value. 125 over 1000. Let's try the next problem over. We're going to do the same thing. Choose whichever way you want. 2 cubed over 10 cubed. And you might agree that these are kind of big numbers. But it's not terribly hard because 2 times 2 times 2 is 8. And 10 times 10 times 10 is 1000. If I do the reduced version, is 1 over 5, which becomes 1 times 1 times 1, and 5 times 5 times 5, which is 1 over 125. Now, if you plug in either of these answers in IXL, they should take it. They should take either of these answers. Now again, what I'm doing is I'm changing my decimal to a fraction to make it easier to multiply. Now, what if I decide not to? Fine. If you do it the classic way, 0.2 times 0.2 times 0.2. So you might multiply 0.2 times 0.2. It's 4. If you remember 2 decimal spaces. So we go 1, 2. And then 0.404 times 0.2. We multiply 2 times 4 is 8. 2 times 0 is 0. And we need 1, 2, 3 decimal places out. Okay, so this is 0.008. Now, if you look back up here, this is 8 divided by 1000, so we need 1, 2, 3 decimal places. So it gives us our same answer. Over here, we have 125 over 1,000. That's 125. How many decimal places? The easy trick is what you're dividing by. The number of zeros is the number of decimal places. 1, 2, 3. Turns out 1/8 is 0.125. Is 1/8. It's half of a quarter. 1 over 4 is a quarter. 1 over 8 is half of a quarter. Now, one more thing is, just as a side trick, if I gave you 0.72 to the 0 power, what is anything to the 0 power we mentioned before as a trick? Anything to the 0 power is equal to 1. Good job. Fast. So anything to the 0 power, that's like a dream come true, right? Anything to the 0 power is going to be 1. Now, what you guys are going to do now for your homework is you guys are going to, one more step here. Today we're going to multiply exponents. Now, here is our last task today. And let me ask you if you could figure out what the scale is. If I say x squared times x cubed, we have 1, 2, 1, 2, 3, all being multiplied. How many x's do we have total? X to the 5th. Good job. Good job. So here's my issue. What if I give you big numbers like x to the 12th and x to the 13th? Do you want me to write a bunch of x's here and you start counting it up? What we realize is that if I'm multiplying powers, we just add the exponents. You're right, it would be 25. And you did that so quickly, great, because you said x is 12 plus 13. Good job, that was fast. Okay, so x to the 25. How do I do that? Is we have this new rule, and the rule is the product of powers. This rule is called product of powers. Product of powers says if I'm multiplying, that's that's letter A, okay? And B, we combine them by saying x to the A plus B, no matter what it is. If I give you a problem, x squared times xy, we don't know what y is, but we can still say x to the 2 plus y. You can always add exponents together if you're multiplying exponents, so powers of the same base. Okay. So if I give you guys 3 squared times 3 to the 5th times 4 squared times 4 to the 5th, how many 3's and 4's we have left? Okay, that's what you guys want to figure out. I'm going to rewrite this as 3, 2 plus 5 times 4, 2 plus 5. And that gives us 7 for each of these. And the idea here is that I can mix and match values around. As long as they have the same base, we can multiply them together. Now, as this gets crazier, if I say 3 squared times 4 squared and 3 to the 5th times 4 to the 5th, just because the order changed, does it mean the answer is any different? Let me ask you this question. If I say 2 times 3 times 2 versus 3 times 2 times 2. Does it make any difference about the order when I'm multiplying stuff together? 2 times 3 times 2 or 3 times 2 times 2. Does the order matter with multiplication? And the answer is no, right? So if the order doesn't matter, you can always remix it up to make it easier on your brain. Or instead just say, hey, how many 3's do we have? We have 7 3's. And we have how many 4's? We have 7 4's. So the order does not matter. What about if I have negative exponents? 3 to the negative 2 times 3 to the 5th. This does not change the rule at all. We would just write 3 to the negative 2 plus 5. We are always adding when we're multiplying exponents. We add them. That means we have 3 to the 3 power now, because 5 minus 2 is 3. Let me give you guys another one. 5 to the 4th times 5 to the negative 7. Okay? So rewrite it as an adding problem. 5 to the 4 minus 7. Because I'm adding a negative. Another way you could write this, if you want to be more clear, plus negative 7. If I add a negative 7, positive times negative is a negative 4. So darn, 4, what am I talking about? 5 to the 4 minus 7 is 5 to the negative 3. Okay. And that's what you would write on your homework. Okay. Now let's do one problem that's a little crazy now. Ready? This is my final example. X to negative 2 times y to the 5th times z to the 4th times x to the 5th times y to the negative 4 and z to the negative 4. Okay. Please combine those together and tell me what final answers do we have. How many x's, how many y's, and how many z's do you guys have? So go ahead and try doing that for a moment. How many x's, how many y's, and then how many z's do we have? If you notice they are all multiplying, so it doesn't matter the order, we can always reorder it if you need to reorder it, or just combine the exponents with the same bases. So product of powers, the word product means multiplying of exponents. Product of powers is multiplying exponents. So looking at the x's, 5 minus 2, 5 minus 2 is 3, positive 3. Looking at the y's, here's the y's. 5 minus 4 is 1. And looking at the z's, 4 minus 4 is 0. What is anything to the 0 power? We said anything to the 0 power is 1, so we don't have to write it. Our final answer is x cubed times y. That is our final answer. We don't write z because z to the 0 is 1. Okay, that's just 1. Okay, that's it.